So way back when I was in middle school, my sister gave me this record. It was really great. This is before I got all into metal. I was still into like Billy Joel and stuff like that. And this was a really great record. It was Paul Simon, right? He had gone to South Africa during apartheid and gotten a bunch of black musicians together, people that all the white people hated, and he wrote a bunch of songs and he recorded this album, and it was really good. Now, keep in mind, he didn't really get into direct trouble, but a lot of people complained because this was apartheid South Africa, and they were like, we had embargoes and sanctions and all that kind of crap, right? And so people got mad that he went down there and highlighted the musical accomplishments and styles of South Africans. And there's an argument to be made that maybe there was some cultural appropriation here. But one thing you can't argue, very first song on that album, The Boy in the Bubble, track 1, during the climactic part of the song, he says, "These are the days of lasers in the jungle." Well, those weren't the days. These are the days. That's what we're going to talk about today. Lasers in the jungle.
I believe these are days, lasers in the jungle, lasers in the jungle somewhere.
All right, so not exactly in the jungle. There seems to be a lot of weapons development going on with navies right now. Now, you may have paid attention to a U.S. Navy project where they were building a railgun. They built this railgun, and it was really awesome, and maybe one day I'll do a video on that, but that's not this video. Also, supposedly, China is deploying coil guns to their infantry, which I'd like to know more about that, but it being China, of course, we're not being told. I mean, we don't know. But over in the United Kingdom, they are working on a new weapon very similar to what everybody's working on. But it's not a railgun. It is a laser! A laser! Ooh. Pew, 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 pew. And they shot something down with it. Before we get too involved talking about this laser, I want to take a moment and say that I have been anti-war pretty much my entire life. I am an Air Force brat, grew up around military, born on an Air Force base and all that. So it's not like I haven't seen military culture, but I really don't like the idea of killing lots of people at once. I don't like the idea of killing one person at a time. So when we're talking about these futuristic weapons, of course we're talking about them in a science fiction context, even though they're really happening. So let's talk about Dragonfire. Now, if you look at the Wikipedia page on laser weapons, you'll see that the Israelis are working on one. We've got both Lockheed Martin and Raytheon in the United States are working on one. Turkey's working on something. Germany and Israel's been working on something that's part of their Drone Dome system, which is an interesting system. Basically, it's a shield. The basic idea behind shields, they put them on things like tanks, and they're looking to put them on aircraft too. But the basic idea is that you have all these computers and they're watching, and so you have all this fire coming in, and the computer observes everything above a certain size, whatever that size is that they consider to be a threat. And if it's above that size and it's going to hit you, then it shoots it out of the sky with something. There are various methods to do this. Small missiles, bullets, computers are tracking, they can carefully aim, that sort of thing. And some of these systems are on the field right now and working pretty decently, I understand. I don't really know for sure, but lasers are part of these systems, or imagine it's part of these systems, because with a laser, you could have, a bullet coming in, and a laser could hit it with enough power in a short enough time to vaporize it by just making it so hot in such a small amount of time that you can go solid, liquid, straight to gas, at which point it'll condensate and become liquid and then solid again. But it'll be much smaller and it won't do any damage when it hits you. And the biggest problem with using lasers so far has been, there are two main problems, are being able to generate enough electricity to power the thing portably, and the fact that when you shoot light through the atmosphere, it has a tendency to diffract. And so you could counter it by smoke bombs, and suddenly your lasers don't work anymore. So I throw some smoke bombs, and now you can't shoot me with a laser anymore. These are some obvious problems. They are working on them. Maybe they'll solve them. Of course, famously, the Strategic Defense Initiative from back in the day, nicknamed Star Wars, was to deploy lasers to shoot down nuclear missiles. Star Wars didn't work out, neither did the movies. So now we're looking at lasers primarily as a defense weapon. So what the UK have done here with their Dragonfire program is they shot down a drone from 2 miles away. Now 2 miles sounds like a long distance. If you shoot guns, 2 miles is a really long distance. But there are two things you need to keep in mind here. Two. Lasers are line of sight weapons, which means you can't shoot around the curvature of the Earth. So they're going to have a limited range anyway. And the second thing to keep in mind, I don't know if someone shot a target down like this before with a laser. I could have done the research, but you know, this is a science fiction channel. We don't care about facts. We speculate. That's what we do. So let's first talk about the weapon. Now, if you've ever used a laser pointer, you know lasers aren't like they show in the movies where you see this one continuous beam, like, there's a beam. That's not how lasers actually work. You don't see the beam, and it moves at the speed of light because it is coherent light, so that's how fast it goes. So you could just be flying along in your plane. You know, I'm flying along in my plane. You know, I'm Snoopy. And then, poof, your plane is crashing and you don't know why. Because you got shot with a laser. That does make targeting difficult. Now, I remember watching, way back during the first Gulf War, I remember watching a news video, those guys at CNN, and they were just freaking the hell out. One guy he was all, oh no, I'm a reporter, I'm hiding in the bathroom. And the others were, you know, putting their cameras, pointing them out the window, and you could see the tracer rounds from the anti-aircraft weapons. And so what they had was they basically had a little machine gun attached to a howitzer or something that could shoot up into the sky. And they would shoot the machine gun with tracer rounds so they could see in the sky where the rounds were going, so that when they fired the big one, they knew where it was going. So I'm shooting near a plane, or boom, you know. You don't get that with a laser. You don't get that at all. If you don't aim your laser well, you don't see what you hit. The laser saw it. Because they shoot so fast, they don't have to lead the target. Which means, I see the plane here, I push the button, I hit the plane. That plane might even be moving faster than sound. It's a supersonic jet. It's a, maybe it's an F-16, I don't know, or F-16 supersonic? I don't know. But sound isn't as fast as light. But one of the limitations with lasers has always been that they hit such a small area. And so you think, well, you're going to shoot a hole through my wing, but I'm going to keep flying, no problem, right? When you heat a pocket of air, what happens? It goes kablooey. Now, back when I was doing mechanic work, we would take the oxyacetylene torch and we point it at concrete. And you may not know this about concrete, but it's not solid. It is a gas-filled porous thing. There's all these little pockets of air that got trapped in during the mixing process or whatever. And you pour it out, and they're there. They're part of the structure. They're part of what makes it such a good insulator. And when you hit it with your oxyacetylene torch, it pops. It pops. So lasers actually do have the potential to explode a target if they hit it in the right place. Say you hit a fuel tank, you vaporize the fuel. Then the fuel vaporizes, mixes with the air, the oxygen, and it becomes a bomb. And you keep your laser pointed at it and you ignite the bomb. So yes, these can be very explosive weapons. So one of the traditional limitations of lasers has been how long it has to stay on the target to be able to do any damage. Because it's not instantaneous. I'm sure that some engineer somewhere has come up with a formula that says you put this much power, then for this much time, and you get this much destruction. And if you increase the power, then the time goes down to get the same level of destruction. There's probably an Ohm's law sort of thing here. So the more powerful the laser, the less focused it has to be. So in this Dragonfire test that shot down a drone, they weren't specific on the kind of drone. Remember, a lot of this is classified, and we're only getting the information they're willing to give to the public. But so they shot down a drone. We don't know if it was like a military drone or if it was just something you know, bought off of Amazon and they just hovered it in the air and whatever. So they shot down a drone. Now, all the reports I've been reading say that firing it for 10 seconds costs the same as running a heater for an hour, whatever. 10 pounds, it costs 10 pounds. This is British money, pounds, so what's that, like 25 American dollars now? Anyway, so they're saying it costs less than 10 pounds per shot, which is great because, I don't know, I guess bullets cost more than that. But bullets run out. If you have a big enough generator, your laser never stops firing. So that is basically the end of our talk about the actual laser fired. Now let's talk about, you know, because this is a science fiction channel, let's talk about exactly what it means to have lasers in your arsenal. Now this is my book. And in this book, lasers are a pretty important part of a ship arsenal. But they're used defensively, and we're going to talk about why I made that choice, you know, in this book, and why I think lasers are primarily a defensive weapon. The countermeasures for lasers are fairly straightforward. You can deflect a laser by just having a mirror. And so some of you are probably thinking, okay, so we'll just put mirrors on everything. Okay, but you're forgetting a really important part of combat. A very important tactical issue here is it's very important to not be seen. This is why assault rifles have a flash suppressor on it. They're there because it makes it harder to see where the shot came from. So someone might shoot you, you know, with their AR-15. I'm in America, so we have to worry about getting shot with AR-15s. If you're not in America, you're worried about getting shot with an M16, which is an AR-15 built for. Anyway, actually, we got the M4s and the P90s. I mean, we got other weapons. Don't worry. I'm in America. We got lots of ways to kill people. So you might hear the shot and be able to turn and look in the direction of the shot and see some more shots, but because of the flash suppressor, you can't see where the shot came from. Well, the same issue applies when you're using mirrors for your armor. If you build a suit of armor out of mirrors so that you won't get hit by lasers, so deflect in every possible direction away from you, that's great, but now you're basically a walking light bulb, because any light that hits you is going to reveal you to everybody around. So you can't really use mirrors as a defense against lasers. Now, smoke and clouds and so forth, that's great. But really the best way to not get hit by a laser is to not be seen by the laser. Put a tree between you and the laser. But if they know you're there, they'll cut the tree down, just cut right through it and hit you anyway. I mean, that is one of the advantages to a laser. I don't know how long it takes. Of course, remember I said power, time, destruction. Increase the power, lower the time, and then you can just cut right through the tree and hit whoever's behind it. Okay, that's fine. The Dragonfire laser is on a ship because it takes a lot of power to run one of these. So it's on a ship. So there are no trees in the ocean. I don't think. I've never actually seen the ocean. Oh, I did that one time. But there weren't any trees. It was California. There weren't any trees. They burned all the trees down. I mean, come on. Climate change, bad electric companies. Yeah. Are there any trees left in California? Oh. In this book, I decided, while I was writing it, that the missile tubes would have lasers around them because it made sense to me that if you were fighting someone who was going to shoot missiles at you, that you would try to put a laser beam into the missile tube. And so they have doors that close, they have mirrors on them to deflect the laser, because deflecting it is nothing. Now when you have a mirror, it's really nothing, I assume. There's probably a certain power of a laser that could cut through a mirror, but I didn't even bother to answer that one. There's a point during the climactic battle where they follow a missile coming out or whatever, and they try to hit the missile while it's still in the tube, because they have to open the door to be able to fire the missile, and they try to hit it in the tube while it's still in the missile tube, and that would do damage to the ship. So that's cool. You should totally... This is why I say I'm a science fiction writer, because this is a science fiction book, and I wrote it. You can't cover an airplane with mirrors. I mean, we spent billions of dollars, trillions maybe, trillions at this point, developing stealth technology precisely so we couldn't be seen. And the more you can't be seen, the easier of a target you are for a laser to hit you and to do some damage. So this is something that could offset our stealth advantage by quite a bit. Luckily, it's being developed by an ally. Well, Turkey's got one, but they're part of NATO, so they're an ally. So in the future, I mean, what can you do? What exactly is going on here? If we can shoot a drone... Okay, let me rephrase that. If the British imperialists can shoot a drone, you know, those idiots that still have a monarch, if they can shoot a drone, they could hang a mirror on a drone, and they could angle that mirror, and they could get around the curvature of the Earth, so they could get a much bigger range. This is important. It's really important. Range matters here because current artillery can fire so far that we can hit. I mean, in World War II, we were hitting targets 40, 50 miles away. Nowadays, we send people out, and they're infantry. This is not special forces work. This is infantry work. We send them out with these laser range finders and their GPS devices and whatever, and they go and they just... You know, they go somewhere and it's called painting the target, and they point the laser, and the laser works with the GPS device and whatever, and transmits the exact location of the target that they pointed the laser at. This is not a laser weapon. And then this gets given to a ground system somewhere, and it can be any of a number of kinds of systems. It could be a carrier 500 miles away that's sent a wing of, you know, F-16s or whatever. I don't know what's on carriers nowadays. I know F-16s are outdated, but I guess we still have them. We haven't given them all to Ukraine yet. Or it could be a gun that's like 200 miles away or 150. I don't actually know the range of those guns. But the point is, they could be very far away. They can't even see. They're shooting over the horizon, and they, you know, the computer tells them, point the gun here and here and whatever, and they shoot. And then they hit the target, usually pretty close anyway, and with enough explosive in the round that they definitely hit the target. So in order to do that with lasers, when you're far enough away, and it's only a few miles, the horizon isn't that far out, unless you're a flat earther, in which case your horizon is the entire planet. But for the rest of us who live in the real world, the horizon isn't that far away. And so a series of drones with mirrors that can deflect, the beam, will be able to shoot around the curvature of the Earth. Let me rephrase that. The British will be able to shoot around the curvature of the Earth. The actual range on this weapon is classified. So we don't really know how far it stays, coherent. One thing that's not widely known about lasers, because usually we use them in such a short distance we don't see it. They actually shoot in a cone. It's not a perfectly straight line like a lightsaber, it's a cone. So the farther away, it still gets bigger. It just doesn't do it on the same inverse square law that non-coherent light does, like from your light bulb. So it is still a lot of energy concentrated in a small area, but the farther you go, the bigger that area gets. It just doesn't get as big as, say, light from a light bulb. What I'm saying is that theoretically, there could be satellites. They could shoot from the surface up to a satellite and then back down to the surface. With that kind of arrangement, I could see it. I could see us sitting here in, central Texas where I'm at, with a big ass laser. We could hit a satellite and have it bounce down from a mirror down to, say, some drone ship out in the middle of the Atlantic, which will bounce it back up to another satellite, which will bounce it back down, and we just burned Moscow to the ground. Except lasers, they don't hit that big. So instead of burning Moscow to the ground, we hit the Kremlin. You don't see the beam, and if we had weapons like that, we could provide artillery support to the Ukraine right now, and nobody would know. But what else can you do with a weapon like that? Obviously, you could shoot satellites from the surface. And we can already do that with a lot of the cruise missiles in the American arsenal, in NATO as a whole. We can already hit satellites. A weapon like this could be used to stop incoming ICBMs. There's always the question on how you stop the incoming ICBM. Because to vaporize the entire missile still takes a whole buttload of energy that we don't have in a laser right now. Even this Dragonfire laser isn't strong enough to vaporize an entire missile. The B in ICBM means ballistic. That means there's no fuel left in the tank when it's coming down, so there's no fuel to ignite. So typically you're looking at burning up the detonate. Typically you're looking to burn up the detonator in the nuclear warhead so that it will not detonate. And so we have MIRVs, so that's multiple something reentry vehicle. They shoot up, and then somewhere around the top of the arc, is that perihelion? Somewhere around there, they separate into a bunch of smaller warheads that drop. You have to hit each of them separately and stop them from detonating. And then when they get there, you take the plutonium warhead out, you put it in your own warhead, and you shoot it right back. Because that's what we do, of course. Right? That is what we do, right? Now, the exact range here is definitely, it's classified for a reason, but one of the things in the news articles I've been reading, one of the concerns that UK military officials have is what happens when they miss? Where does the beam go when you miss? And that's a really important question to answer because they don't want to accidentally shoot their GPS satellite. Well, our GPS satellite. We're all in the same alliance. What if they accidentally hit, the ISS? What if it goes out farther? What if they hit the moon? What if there's like a city on the moon and they're trying to hit a drone that's flying overhead and the moon happens to be right there and they miss the drone or they hit it, whatever, and they go through the drone, but whatever. And then the beam hits the moon like 0.2 seconds later or something. It's actually, I think, a 6-second delay to the moon. And then they kill like 300 civilians on the moon. I mean, it's a valid question. What is the range on a laser weapon? As a science fiction writer, that has me wondering, what if some alien species on some other planet builds a giant fucking laser and shoots the Earth with it? And they built it like 200 years ago, but they're 201 light years away from us. So getting back to the primary role of this weapon, of any laser weapon really, the primary role is still going to be defensive. They kind of sound cool used offensively, but the countermeasures that you can use to defeat a laser, you could have 20 people stomp around in the dirt and refract the laser enough that it won't hit you, or that it won't have enough power to do any real damage. Once you start dispersing a laser, that power drop is sharp. So the laser is going to be effective only as long as you have control over the atmosphere in which you are firing it. Now, in a sneak attack or an assassination attempt that you happen to want to spend, $1.5 trillion on, so you launched all the satellites and everything, sure. Your first shot, fine, you got that one. Maybe your second and third shots too, but once enough people have lasers, countermeasures will be deployed. You won't be able to assassinate people with it either. So tank defense, ship defense, being able to stop incoming projectiles, that's going to be the primary use of these lasers. And in this book, that's the primary use of lasers in this book too. In science fiction, we often call that a point defense. I honestly don't know why we call it that, we just do. And that's our first significant shield technology. So what does this kind of technology really mean for our future? As much as I hate war, we've gotten a lot of really important technology out of our military investments. We got the internet, we got everything about computers came about. I mean, you do know that the microprocessor was invented to guide missiles originally, right? I mean, that's literally the first use of a microprocessor, was to make sure a missile could hit its target. Now, microprocessors are in everything. I mean, the CPU is a microprocessor that we got DARPA out of military investment. We got GPS. We've got a lot of really important things, really useful things that make our modern world work, all started as military projects. So what does it really mean to have a laser like this? And the answer is, because the range is classified, I can't really give a solid answer here. But the first step in figuring out how to transmit power generated in orbit down to the surface is being able to transmit the power. And that's what the military does. They transmit power. We call it force projection, we call it firing rounds, we call it blowing up the bad guys. Even though, I mean, I'm an American, we're usually the bad guys, let's be honest. But if you want to put a solar array in orbit, which can capture a hell of a lot more energy than a solar array here on Earth, you need some way to transmit that power. Now, Heinlein, back in the day, suggested using microwaves for it. Heinlein was not a scientist, and neither am I. Obviously, a lot of development has happened since then, and that development is very important because now we know the microwaves aren't the way to do it. But a laser like this, if we can recover even 50% of the energy that this laser transmits from orbit, I can't even begin to talk about this. That same 100-watt solar panel that you can put on top of your house, if you put it in orbit, will generate like 500 watts. I mean, that's the difference. And with mirrors and stuff to make sure that they, so they don't have to be in geostationary orbit, or maybe you're going to have some there, you're going to have some in other orbits, to make sure you grab energy when the sun is not shining on you. You can still get solar power if you can put solar panels on the other side of the planet, transmit the energy with a laser. So I'm excited. They shot down a drone. I'm excited. I'm really excited about this. We already have laser cutting, laser welding. I mean, we have laser doing all sorts of things with it. You might think of your laser as being a laser pointer because that's what most of us use a laser for. If you're a gun nut, you probably also use a laser range finder on your gun, to shoot deer, of course, because that's who you're preparing to shoot. You're not preparing to shoot any people. We know that. But if we can figure out how to collect this energy, and that would make a great countermeasure too. I mean, imagine you got your F-22 Raptor, which is the best plane we have, by the way. You have your F-22 Raptor just flying along, and he's running out of energy, and so he's going to fall out of the sky, and so Russia, of course, it's got to be Russia, decides to shoot them with a laser, and they're able to recharge and just keep going. That would be the best countermeasure, wouldn't it? Just collect the energy and use it for yourself. Then you could fire another laser back, and they could collect the energy. And they could use that to fire another laser. And then you could collect that and fire another laser. And then fire another one, and fire another one, fire another one, fire another one, fire another one, fire another one. Also, one of the things we get with high-powered lasers is longer range. And there's a lot of indirect things we'll get from this. We're going to learn better how to control lasers over longer distances. We're going to be able to do things with lasers we haven't been able to do before. And we already do, I mean, NASA already uses lasers to send signals. You know, in the NASA Deep Space Network, I think there are some lasers involved. It kind of doesn't matter because it's all electromagnetic. So the Dragonfire project is interesting. I like thinking about lasers. If you like this video, click like. If you think the people that watch the other things you watch would like it, subscribe. If you would like notifications when I post a new video, ring the bell. You can also go down there, click on the Patreon link. If you'd like to see more videos, go check out my Patreon. In the meantime, have a good evening.